Welcome to Data Skeptic Machine Intelligence, our podcast series exploring contemporary topics in artificial general intelligence and large language models. Lately, I hear more people sharing concern than optimism about ChatGPT. What about plagiarism? What about unemployment? What about high school students using these things to write their own essays? To me personally, that's not cheating. They're just using a tool. I know a lot of you disagree with me. I'd like to think I'm future-leaning. Either way, there's certainly an optimistic side to all of this. AI, like any technology, can do good and evil. And one of the things it has the potential to do great good at is personalized learning. One teacher typically has, 20 to 30 students? Sometimes thousands? A human teacher can't give every single student personalized attention. While perhaps inferior, an AI teacher can give them virtually infinite attention. It stands to reason that a proper deployment of these technologies for education can offer us profound good in the efficiency and effectiveness of teaching. At least that's my opinion. We're going to go beyond opinion in today's interview and talk to an expert researching this area. What does the future look like in mathematics education, given advancements in AI? That's the core question of today's interview.
I'm Steven Van Vaerenbergh. I work at University of Cantabria, a university in the north of Spain, and I work in two areas, artificial intelligence and mathematics education.
Can you expand on both those areas? Specifically, what are some of your interests?
As a matter of fact, I started my research career in signal processing, and I quickly turned to machine learning. And so I worked for quite some years, around 15 years, on machine learning techniques, mainly to be used in signal processing, but also more fundamental machine learning theory. That has always been a great interest of mine, machine learning and artificial intelligence in general. And some 4 or 5 years ago, I had the opportunity to start working in another interest of mine, which is mathematics education. So I took that opportunity and I've been researching in that area since then. And since I have all this luggage or this experience, I may call it, from machine learning and artificial intelligence, my goal from that point on has been to research how AI can be used in mathematics education. And so that has been a major question that I've been trying to answer over the last 2, 3, maybe 4 years. That's more or less what I'm working in at the moment.
Well, what AI can do or what sort of proficiencies we see coming out of machine learning is evolving pretty quickly, even within that short time period you mentioned. How has that momentum affected your work?
The last 6 months have been very strange with generative AI. When I started working and I did the first work here, the first investigation from 2020 to 2022, more or less, the changes and the evolving technologies in AI did not really affect what I was researching at that point. My question was really, where is AI being applied in mathematics education and where can it be applied? I found some use cases that were already more or less established. So I would say that the latest advances in AI did not really alter how these use cases were being used in practice. I should give some examples, probably. Well, when I started researching here, my idea was that, okay, I knew a bit about AI and I knew that AI is being applied everywhere in all industries, in all areas, even in government administration and in education. So it's being applied everywhere. So when I started in mathematics education, I wondered, okay, so since AI is being applied everywhere, where is it applied in mathematics education? So I started looking for examples of apps or online programs maybe that used AI. One of the first I found that was very interesting is this phone app called Photomath. And don't know if you're familiar with that.
I'm not. Could you give a quick background on it?
There's a group of people who are very familiar with that, and those are the secondary school students, because this is an app. When you open it, it starts your camera and you can take a picture of a mathematical problem. So, for instance, a set of equations. If you've written them down on a paper, the app allows you to take a picture of this, and instantaneously you get the solution and all of the steps needed to explain the solution. If you don't like the way it's solved, you can ask for another way. This, I think, launched in 2014. and it was an instant hit among the students that found out about it. It was not very popular by their teachers because, as you can imagine, this was used for homework typically. So teachers gave them homework, and suddenly all the homework started coming back perfect scores. I actually read an anecdote about that, a teacher who wrote about this and who was very curious about how could this happen, because he also noticed that while their homeworks were perfect, their exams were not. And parents even complained because they didn't understand either. So this teacher found out that all the students were using at home this app to solve their homework. This is now pretty widespread. Photomath was the first one that really got popular, but all the big guys, the big companies started their own. Google has one, Microsoft has one, and there are tens of clones out there now. But that is one of the first examples I noticed of artificial intelligence being used for studying or for learning mathematics. Well, in this case, it's not really what the teachers would recommend, but certainly it can help you solve something. And since it gives you the steps to solve it, you can actually learn from it. In this specific area of mathematics education, we saw that it does force us to rethink things. And I used that example a lot of times when I was talking about calculators, when I talk to people about calculators, because in the 70s, we had kind of the same problem. Pocket calculators appeared. It wasn't clear how they could be used in class or by students. There was a lot of discussion about if this pocket calculators should be allowed. Some teachers thought that pocket calculators would cause students to stop thinking, to stop reasoning. Now, it turned out not to be that bad. We now know where we can use pocket calculators, where we cannot use them. And I see this evolution in calculators. And talking about this type of photo calculators, I found them interesting because obviously they use AI. And when I wanted to map, let's say, the AI that's being used in mathematics education, I have a colleague who works on this as well. He's my co-author for this book chapter that we wrote this in. He's called Adrián Pérez Suay of the University of Valencia in Spain. And we analyzed this and we thought, okay, let's see how this actually works, because you take a picture of a mathematics problem, it solves this and it explains this. So we wanted to classify all the types of artificial intelligence that are involved here, and then make some kind of a taxonomy, which is what we did then. But just to come back to this example of the photo calculator, clearly it has a first stage in which a picture is taken and some kind of OCR, optical character recognition, is performed. What that does is it takes the picture information, all the pixels, and transforms it into a mathematical representation, a set of equations, for instance, or it might be a function that has to be plotted. So the first stage is an AI that performs optical character recognition. Then comes the second stage. What you do then, what it does then, is it needs to solve this. So it takes the mathematical equation, performs something of a solver process. Now, for some problems, this is easy. If it's a mathematical equation or a set of equations, there are some standard procedures to solve this, and some very old procedures even. But sometimes it might be more difficult. We thought, we could call this module that could be called a solver, right? This is something that solves a mathematical problem and produces a solution. So there we have a second module. It doesn't necessarily have to be AI, but still it has to solve this. And sometimes it has to be AI. In this particular application, it's a very simple solver, but there are more complex ones as well. Like, I don't know if you're familiar with Wolfram Alpha, which is a computational engine that can solve a lot of different types of mathematical problems. So it takes in some problem and it solves it basically. To go back to this app, once it's solved, you need a third step. You need it to explain everything. So this is actually an important area in machine learning right now, explainable ML, because neural networks, for instance, are typically black box. They might solve something, but they don't tell you how it's done or what features were important. Once you get the solution to the problem, you still need the steps to solve this. And we call that an explainer. So that's the third module, that's an explainer. So we already saw these three different parts. This app includes these three different parts of AI. Obviously, we didn't do that. This is something that we classified like this after looking at some more apps and some more applications. But here we already found three of the basic uses of AI in, let's say, mathematics education or applied mathematics in apps, for instance. So that is one of the examples I think is very interesting. And well, these are photo calculators. You may not be familiar with it, but if you are a student or a teacher in secondary school, then you would probably know this.
Yeah, I expect so. If I were taking even geometry, trig, calculus, any of those sorts of levels of math, that a theorem prover like this would be useful to me.
Yes,
But I think the part that's going to be controversial is the solver, not the OCR. The fact that student A could handwrite their notes and type them into a computer, or another student B could take a photo and get a digitized version. I don't think teachers object to that. Where do you stand on the use of the solver?
I think it may be used in class, but only to give hints or to maybe to prove something without giving the entire proof, just to say if a conjecture is right or wrong, and then hand it to the student to perform the actual proof. Because I think using these technologies in either secondary or primary school is a bit dangerous. We should somehow limit the use of them, because these are students that are still, they're learning to think, they're learning to solve things, and we must avoid, I think, that they take the shortcut by using these methods and skip some of the learning processes they need to acquire.
Well, we touched on a couple of the layers in the camera calculator example. Did we hit on everything in the taxonomy, or are there other ways in which AI can impact math education?
Well, we made this taxonomy by looking at some more examples, because there are other examples out there, like, for instance, the automated theorem provers, which are being used for all kinds of demonstrations now. There's a good example in geometry, so the software GeoGebra, which is quite widespread. This software has now included also an automatic theorem prover, which is a prover for geometric theorems, which is quite handy. But it only tells you the result. It doesn't tell you the steps. So I've seen that used in class, where students first have to make some construction, then try to see if something always holds. Then they ask the prover if the property always holds or not. The prover works like an oracle that tells it, and then the last step is the student has to perform the actual proof. But this falls within the class of the reasoners, the solvers. I mean, there is one more class that we identified. So we had these three. The last one is maybe a little more generic. It's data mining, because we see that a lot of applications are actually about processing huge amounts of data and trying to perform some prediction. We can see that in learning management systems, which have a lot of usage data from the students. Like, for instance, student accesses something, some resource, then solves a problem, fails the first time, then repeats it. This time he gets it right. In these platforms, there's a lot of data that can be used to, can be mined, can be used to get useful information that can help to build profiles of the student models, they're called, or it can help to predict the student performance. So this is a more generic category of techniques that are actually what we call them, basically data mining techniques. I think they were called this, like that. Well, with that, we have 4 classes. Well, it's actually called data-driven modeling in the taxonomy we proposed, but it's a more generic category.
Are you a software engineer looking to make an impact with one of the world's premier data and technology companies? Well, you should look into Bloomberg. Bloomberg is building the world's most trusted information network for financial professionals. And right now, they're looking for engineers to join them. You'll be part of a team that builds and delivers tools to help the world's leading business and financial decision makers surface relevant information in an ever-changing ocean of data, so that they can act quickly on it. Their software engineers build solutions that are relied on by more than 350,000 financial professionals all around the world, using them to make critical business decisions. Bloomberg believes in using the right tool for the job. Their stack includes C++, JavaScript, TypeScript, and Python, all languages I love. The company is committed to building a diverse workforce full of fresh perspectives. Finding your new career can be hard, but if you find the right company, it can be rewarding and fun. Learn more about this opportunity by visiting bloomberg.com/careers. That's bloomberg.com/careers. And I'm curious if you have any thoughts on the short-term changes that we might see in math education. Tools like ChatGPT, and even though this, visual calculator is a bit old, these are sort of seem like they could be game-changing tools. Are we going to see a lot of rollouts in the near future?
So what we're seeing already are a lot of experiments. For instance, a few weeks ago, there was this announcement by Sal Khan, the founder of Khan Academy, who is using this technology in intelligent tutors for online courses. I think we will see an enormous advancement in the tutors that are being implemented. Tutors in the sense of some form of chatbot that help the student to learn, basically. They're also going to help the teachers a lot because teachers are many times overworked and have lots of things to do. And these technologies, in my experience, they can help with almost any task that is related with education. So teachers have to prepare classes, have to prepare exams, have to make rubrics, have to think of what difficulties students could have. ChatGPT and related technologies, they help. They can help teachers to prepare all of this. They can help teachers to. They can help them by giving them inspiration. I think it's going to change the way teachers are going to evaluate their students because I think even the goals are going to change the goals of the evaluations. It might even change in-person classes because there's a lot of methodologies nowadays. It's not always like traditionally we typically had master classes and classes of exercises, but now you have all these new methodologies. You have flipped classroom in which the student prepares the theory and then explains it to the other students. You have collaborative learning, you have project-based learning, you have all these new methodologies. And I think it can, well, help or it can be used in all of these new methodologies. In short, I think we're seeing a lot of experiments now, and it's a very interesting time. And I think this is one technology that is actually it's not a technology that's gradual as a lot of other ones have been, but it's very abrupt. It changes everything a lot. And in education, well, at least here where I am in Europe, the educational methodologies they take time to change, and the curriculum takes years to change, for instance. But teachers can do individual things, obviously, in their schools, but it will take some time, I think. And it's only going to be the most audacious, maybe, teachers that start experimenting with this right now. But I think it has at least the potential to change almost any aspect of education.
I'm very optimistic about those intelligent tutoring systems you were mentioning in the paper and in our earlier discussion. But I know one of the main criticisms people are quick to bring to the table when discussing large language models is their ability to hallucinate. It would certainly be bad for a student to show up to a class after working with a tutor and be filled with all types of incorrect ideas. Do you share this concern?
Certainly. When we use these systems, we have to have the capability to think critically. I think we should only use these systems. I'm talking about ChatGPT generically right now. We should use it if we know how to do this task by ourselves, but we want to speed it up, or if we're not inspired someday and we need some more inspiration. But we should not use it for things that we really don't know how to do, because maybe it produces results for which we cannot verify that they're correct. And that is key here. We always have to have the possibility to check if it's correct. If we're talking about tutoring systems, these are for learning. Students don't have the capability of checking if things are correct because they're learning them. If the tutor hallucinates, this is obviously a problem. I'm going to mention again this demo by Sal Khan of Khan Academy. They seem to have worked out something. They have a tutor which is somehow restricted in the sense that it has very strict instructions, I guess, because I don't know how they avoid hallucinations, but they seem to have found some way at least. For instance, if a student asks for a solution, the tutor will say that it cannot give the solution, but it will try to act as a teacher would do. It would try to make the student think for him or herself. If you're going to ask ChatGPT, for instance, nowadays, if you're going to ask it to solve a mathematical problem, you obviously know that ChatGPT doesn't solve mathematics correctly, right?
Not reliably, but once in a while, but yeah, not reliably.
That's right, once in a while. So you could give it a mathematics problem and it might start correctly, perform a few correct steps, but then suddenly make an error that is totally a basic error. It would make no sense that after doing these very first complex steps, it suddenly makes a beginner's error. So it does these things that is related to the hallucinations it does. And I assume it is because it is a large language model. It is actually replicating patterns it found in language, and it is not following some kind of a logical reasoning sequence module. This is documented. There was the founder of Wolfram Alpha, Steven Wolfram, who actually wrote a blog post on this. He said that, well, ChatGPT fails often when it tries to solve a mathematical problem. But he had the solution, he said, because he has been working for years on this computational engine, which is Wolfram Alpha, which works very well. You formulate a mathematical problem, and it runs its calculations, it understands the data, and it produces a solution. This works very fine for a lot of problems, but if you give it a phrase that is not very well formulated, it might not understand it, so then it doesn't work. So what he said is, hey, we have to combine these two things. We have to combine ChatGPT with Wolfram Alpha, because ChatGPT can understand what the user wants and can translate this into a formulation that Wolfram Alpha understands. And then Wolfram Alpha can do the solving, can send the result back to ChatGPT, and then ChatGPT can do the explanation, is what he wrote. And he gave some examples of this. I think the example was, what is the distance from Tokyo to Paris, for instance? ChatGPT didn't know. It produced some calculation, but it was not correct. So if you give Wolfram Alpha the same phrase, it understands the parts of the phrase and it starts calculating, and it gives the correct answer. If you make the phrase longer or if you add extra data, maybe Wolfram will fail. And so he gave a manual example, and I call it manual because he started giving the prompt to ChatGPT, and he asked ChatGPT to translate this into something that Wolfram Alpha would understand. Then the output is what he gave to Wolfram Alpha. Wolfram Alpha produced a solution, and then he went back to ChatGPT. He said, okay, this is a solution from Wolfram Alpha. Translate this to human readable reasoning. And ChatGPT did that perfectly fine. That is what he wrote in January. And then 2 months later, they actually implemented this. So that was in March when ChatGPT plugins were launched. With the launch, they also announced one of the first plugins, which was the Wolfram plugin. So if you have ChatGPT Plus, the subscription model, you can activate this problem. And when ChatGPT notices that you're asking it to solve a mathematical problem, it will first it will translate that problem to something Wolfram might understand, and then it will consult Wolfram and it will do the entire process. I found that very interesting. They completely automated this, and this means that ChatGPT can be used to solve mathematical problems, but you need this plugin installed in order for it to not hallucinate.
Well, I think a lot about the possibilities here, and for me, it would be a major dream come true if a system like that had a GPT large language model interface, but a plugin to Wolfram Alpha. I mean, when students are in math class, they have typically one teacher. That teacher has limited time to share with each student. If we could supplement them by giving them each a personalized automated tutoring system, it just seems like a dream come true. If the technology is at that level, are we there today, or do you think we'll be there in the near future?
From what I've seen, I think we're there. These tutors have to be fine-tuned, but as you know, probably you can get to maybe 90% of a tutor by formulating a correct prompt. But we want it to be 100%. So, and for that, there needs to be some development, some configuration. From what I've seen by Khan Academy, for instance, I think we can have these tutors in a matter of months. And the case you mentioned is very interesting because this has been a goal of lots of researchers for years. And it actually goes back to, I think, the 70s or the 80s, in which there was a study by Bloom, which is very famous in this context, who found that if you map the performance of a typical class, you will get a bell curve. You have some average students, some below, some above. You will have some exceptional students. Well, this was a normal class with one teacher. Their experiment was to give to each student individual one-to-one tutoring and to see how their performance changed. They found that if they gave one-to-one tutoring to each student individually, this performance, this bell curve, actually moved a lot to higher scores. They found that on average, students gained 2 standard deviations of performance compared to one teacher per class. And so that means average students after the one-to-one tutoring became exceptional students. Below average students became above average students. This is a classic experiment, and this actually showed that one-to-one tutoring is very important. Well, as a matter of fact, there was another factor involved. There was also mastery involved. So in order to go to the next topic, first there had to be mastery of the current topic. And the problem was then, okay, if we can help the students that much by one-to-one tutoring, how are we going to do it? Because we don't have enough teachers, not enough tutors. So, and that has been the motivation for artificial intelligence for lots of years since then. So the promise was that if we get an artificial intelligence that is smart enough, we can solve this 2 sigma problem, it's called. We can give an individual tutor to every student. I think we're very close to that now. So we could give an individual tutor to every student. I do have a side note on that, because if we have a class, traditional class, in which the teacher is in front of his students and he's teaching them and they do all kinds of exercises and the normal class routines, I don't think we're going to change that to students who have their own personal tutor in front of them, because that would mean they're suddenly working with their tablet or their computer. The individual tutor, I think, will work very well for the learning that is currently individualized. Like if we log on to a learning platform online, I think that is where we will see these individual tutors first, because there's no group dynamics in these ways of teaching. Well, obviously these platforms have their forums, etc. But most of the time it's a student reading some material or seeing some videos and then maybe having some interactions with a tutor, doing some tests. So I think this is going to be revolutionized a lot. That's individual learning. And if we go to the in-person class, I'm not sure how it's going to affect there, because obviously we're not going to put the computer in front of every student and let them interact only with the tutor. Since there are group dynamics, and since students learn a lot from seeing how other students learn and from interacting with other students, I think that is some area where we still have to think about it.
Do you have a sense of where it might have strengths or weaknesses? For example, will out of the gate it be excellent for geometry, but not so great for helping you with differential equations or something like that?
I think it might be the other way around.
Interesting.
I tried some minor experiments. I'm not sure if it understands geometry, for instance. It has read a lot of things and it knows if you make a construction, like you draw a triangle and then on 2 of the sides you mark the midpoints and then connect them, what happens? As a matter of fact, we see some parallel lines there. We can prove this. But these are proofs that have been written time and time again on the internet, and the model has learned that, and it simply replicates this if you ask it for that. This is an intuition, but I think that differential equations, well, these can be solved by classical solvers and by solvers like Wolfram Alpha. So I think these will be supported much quicker than geometry. Geometrical reasoning is not that easy for these technologies. As a matter of fact, these models, they take in text data. That's because they work, they process text. Some of them also accept images right now, but I did some tests and they don't really understand what is in the image. So there are some tests, for instance, for children, that is to know their mathematical age, and a child is shown some images like you have 5 stars on the right, 2 stars on the left, and it starts with simple questions. On what side do you see more stars? And the child has to answer that, and then it becomes more complex. You get, for instance, different numbers. They have to be sorted. You get operations. They have to be solved. And part of it is arithmetic. It's simply working on numbers, but another part is visual, and there's even geometrical tests. And I fed some of these geometry tests to the, I don't remember which one it was, but their levels are more or less equivalent, but they don't understand the image a lot. They don't understand the image. I think that is pretty important for geometric reasoning. The image itself should give the solver some intuitions to guide it how to solve this. So I think geometry is still a bit off, a bit far off. And I think there are other fields like what was it, differential equations. We might see it solve these problems much earlier than geometry, for instance. But I think geometry is one of the very interesting fields. I mentioned earlier that there are programs like GeoGebra, which have a theorem prover included, but this is a symbolic prover. Also, if we talk about AI in mathematics, traditionally the AI that was implemented was symbolic. You can think of it as being rule-based or being equation-based. And what we see now, and this is a very interesting evolution, ChatGPT is not symbolic. It's, you could call it probabilistic. It looks for frequencies. It looks for probabilities. So we see that where we have decades of work of symbolic AI, suddenly it's being surpassed by an AI that is probability based. Well, not really surpassed because it hallucinates a lot of the time, but we see that it does very advanced things. And we need a mix of both.
Well, it's an exciting time to be at the intersection of AI and math education, in my opinion. There's a lot to be built and deployed, and there's also theory like your paper to be done, and probably some experimentation to look at as well. I'm curious if you could share some thoughts on the direction you're headed in your research.
Well, for me, the immediate next steps would be to investigate the possibilities of intelligent tutoring systems. If we look at what is in the open source community, what is available in the open source community, and what is available in typical learning management systems, there are not really any very accessible intelligent tutoring systems. And I think that's going to change. For starters, we can see that large language models are giving these tutoring systems superpowers. These systems, they're typically built, they're made out of blocks. One of the blocks which will try to model the student, another block will try to will be the tutor and will be responsible for determining which is the next task to give to the student, or if he has to ask some question to the student. Most of the literature that has been done like this has to be revised with large language models in mind. We've seen some experiments already using ChatGPT and GPT-related technologies. So for me, the immediate work would be to look into how that can be done. The interesting thing is that the field is more accessible than ever because since these models work by inputting simple English or any other languages, you don't even have to program that much anymore. By simply forming a good enough prompt, you can get a lot of the functionality done. So I think that entry is much easier now. I think these models have to be revised. And I think in the near future, we will see a lot of much more advanced tutoring systems than we had before. So I will be looking into that.
Well, I look forward to that. I think there's definitely major room for improvement here. It's a new emerging market, really.
Yeah, some small remark about this is there's an interesting evolution in these technologies. Well, I noticed this last year actually when the DALI image generation technology came out. I found that spectacular, and this is actually what fueled my interest in all this generative AI. But what really changed things was in August when Stable Diffusion came out. This was an open source model that for me changed a lot. Well, on the one hand, I thought, okay, Pandora's box is opened now. People will do everything that was forbidden with DALI, like generating pictures of politicians. At the same time, we saw the open source community in action, and we saw that they built interfaces. They found ways to train new models more efficiently. I think the open source community will play a big role here because we're seeing the same now in text-based models and large language models for text. I think we probably will see first some very good models, some very good tutors built on GPT, etc. Probably a few years later, or maybe months, because things are moving very fast now. Probably a few months later, we will see standard solutions built on open source technology. That's an intuition I think could happen.
Oh, I'd love to see that as well. Exciting ideas. Stephen, tell listeners where they can follow you online.
To follow me online, you can check my Twitter. I'm at Steven2358. And that's basically it. I have LinkedIn, but I'm not very active on LinkedIn. I usually post some machine learning related info on Twitter and often some more fun things as well.
Sounds good to me. We'll have a link to your Twitter in the show notes for listeners to follow up. Thank you so much for taking the time to come on and share your work.
Thanks for having me. This was fun.
That concludes this installment of Data Skeptic Machine Intelligence. Join us again next week when we put AI to the test. Not the Turing test, it doesn't pass that yet. No, we put it to the test on theory of mind tasks. See you next week.